Okay, we'll pick up where we left off, number 24. So when you have these exponential equations, now exponential means there's a number as the base and a variable as the exponent. What you've got to do is figure out what power of 2 is equal to 512. Now I know you see the answer right there, but that's not something you have to have memorized. It's okay if you've got to guess and check in your calculator. So for example, you might say something like 2 raised to the 7th. Say, okay, that's too small. And then try 2 raised to the 9th. And be like, okay, there it is. So you can guess and check until you get the right answer. So once you find out what that big number is in terms of that base of 2, then you realize, okay, the two bases are the same. Those are both 2. That means their exponents must also be the same. Otherwise, this wouldn't work. So you can set the exponents equal to each other. So on this one, it's simple as saying, well, if the bases are both 2, then x must equal 9. Now the process on number 25 is similar. It takes a couple more steps because this time it's not just x in the exponent. It's got a little more to work with. But you can again guess and check in your calculator to figure out what power of 3 will give you 243. Spoiler alert, it's 5. So 3 to the 5th equals 243. So I'm replacing 243 with 3 to the 5th because they mean the same thing. They equal the same thing. So once you see the bases are the same, you can ignore them. Say it must be true that the exponents are equal to each other. So I set 2x plus 1 equal to 5. Subtract 1 from both sides, get 2x equals 4. Divide both sides by 2 and find out that x must be equal to 2. Okay, now on my calculator this may be a little tricky. On yours I'll tell you what you need to do is do 64, then do the caret button, then do parentheses 5 over 6. And once you do that, it will give you 32. 81, you'll work the same method. You'll do 81, use the caret button to make an exponent, and the parentheses are essential. It will not give you the right answer if you don't put that in parentheses. But that will give you 243 when you plug it in. Okay, on 28, we're back to the fact that when we multiply things together, the coefficients we multiply just like normal. 6 times negative 3 is negative 18. When we multiply variables with exponents, we add them together. So t squared times t to the 5th, we say 2 plus 5 is 7. Into the 6th times into the 3rd, 6 plus 3 is 9. Now in 29, we're using the rule where if you have an exponent raised to an exponent, you multiply them together. So 3 times 4 gives us 12 for the w. 3 times 6 gives us 18 for the y. Then on 30, we're combining those two rules together. So you have to first take care of the exponents that are outside the parentheses. So the 5 can just stay 5. It's got nothing else going on. We have to do 3 times 4 to get a to the 12th. Then there's an understood 1 exponent with the b. 1 times 4 is 4. Which also makes sense. b to the 4th. Oh, that's b to the 4th. And then we'll apply this squared to both things inside here. A squared. And then 2 times 2 is 4. But that's just step 1 because we still have to combine these like terms. 5 is still just itself 5. But we have to add 12 and 2 to get 14 for the exponent of a. 4 plus 4 is 8 for the exponent of b. (31) is actually simple, at least simpler than the 3 we just did. We just have to look for the like terms and add their exponents together. So k to the 6th times k to the 15th, we do 6 plus 5 and get 11 for the exponent. M to the 7th times m to the 8th, we do 7 plus 8 and get 15 for the exponent. When you have an exponent that's a fraction. The denominator of that fraction is the root that's happening. So these two things mean the exact same thing. 17 to the 1/3 power is the same thing as the cube root of 7. So when they write a fraction in an exponent, the denominator is the root, the numerator is the power, which that just means it's 17 to the first power, but we have to take the third root of it. So on 33, since the denominator is 7, we're doing the 7th root. You do have to pay attention to make sure you only put inside the radical whatever the exponent is applying to. So x is being raised to the 1/7, not 5. So only x goes inside the root, or the radical. The 5 is left outside. Okay, on 34, we're using the exponent rules where we're dividing. Remember, coefficients you just treat like normal, just like you've done since 3rd grade. 9 divided by 3 is 3. But when it comes to the exponents, when you're dividing, you subtract. 3 minus -2 is 5. -4 minus 2 is -6. And you don't have to put it over 1. You can just leave it just what's on top. But since this did not say we have to have positive exponents, this answer would be fine. But if you'd prefer to have positive exponents, or if you're on one of the sections where it says you must, then the way to fix that is to take this thing with a negative exponent, move it to the denominator, and that changes the exponent to be a positive. On 35, the first step is to apply these exponents that are outside the parentheses. So I do -10 to the 3rd power, or -10 cubed, and you get -1000. 2 times 2 is 6 for the x. 2 times 3 is 6 for the x. 2 times 3 is 6 for the y. In the denominator, 5 cubed is 125. 2 times 3 is 6. Y cubed is y cubed. Well, you can type this in your calculator. -1000 divided by 125 is -8. So all I did was just divide those two numbers. Now x to the 6th divided by x to the 6th is 1, so those essentially just cancel each other out. But then here, we subtract the exponents. 6 minus 3 is 3. Okay, when you're asked to simplify a radical, what you're trying to do is figure out what's the number that goes into that number that I can take the square root of. So for 27, 9 is a number we can take the square root of. And 9 times 3 is equal to 27. So these two are equivalent to each other. Then we take the square root of 9, and it gives us a 3 on the outside, because the square root's already been taken of that. Square root of 9 is 3. But we don't know the square root of 3, so we just have to leave that 3 inside. On 37, same idea, only we're looking at 20 this time. We've got to think, what number goes into 20 that we can take the square root of? Well, not 20, not 10, not 5. 4. We can take the square root of 4. So we'll rewrite 20 as 4 times 5. We'll take the square root of 4, which is 2, and this 5 just stays for now. It doesn't change. We're multiplying all these things together. Square root of 4 is 2. Square root of 5 we don't know, so we leave it inside. And this is why I point out we're multiplying. So since we pulled a 2 out front, you have to do 5 times 2 to get 10 times the square root of 5. Okay, on 38, since these two have identical radicals, and by that I mean it's square root of 21 and square root of 21, you can think of it like this. You have 8 of this thing, and you're subtracting 5 of those things. So if you had 8 things, you subtract 5 of them, you're left with 3 of them. So it's just like it was 8x minus 5x is 3x. 8 of those square roots minus 5 of those square roots would be 3 of those square roots. On 39, we want to treat the number and the variables kind of separately. So first with the numbers, we do the same thing we did on previous problems and say what can go into 50 evenly that we can take the square root of. That'd be 25. So we rewrite 50 as 25 times 2. The square root of 25 is 5, so that's why it's outside the radical. Square root of 2 we don't know, so we leave it inside the radical. I think the simplest way to think about the variables is a square root. Actually, let me point this out. We talked about earlier how if we have an exponent that's a fraction, that's a 1/2. I don't know why the camera's a little unclear there. It's the same as the square root of that. So since we're taking the square root, there's an understood 2 with those, we just never write it. A square root is the same thing as cutting the exponents in half. So we can divide 4 by 2 and get 2. We can divide 5 by 2 and get 2 with a remainder of 1. So since 2 goes into 5 twice, we can bring out 2 d's, but we have a remainder of 1, so there's 1 d that's still inside the radical. Another way you can think about it is you can pull out however many pairs you have. So 4 is 2 pairs, so we can pull out 2 c's. D is 2 pairs, but then 1 loner, so the loner has to stay inside. 40, we need to distribute, so we do square root of 5 times square root of 10. Since they're both inside of a square root, we can just say 5 times 10 and get 50. Square root of 5 times 15, same. Since they're both inside the square root, we can just say 5 times 15 and get 75. So we want to reduce these by thinking what number can go into these that we can take the square root of. Well, it turns out to be 25 for both of them. It doesn't have to turn out to be the same one, it just does in this particular problem. So I change 50 to 25 times 2. I change 75 to 25 times 3. Square root of 25 is 5, and we leave the 2 inside. Square root of 25 is 5, and we leave the 3 inside. All right, who's up for some simpler problems for a little bit? Whew, here we go. So on 41, they say write it in standard form. Standard form means you put the biggest exponent piece first, then the next biggest exponent, then the next biggest, until you get down to the one that has no variable at all. And the leading coefficient is always the coefficient in front of the biggest exponent. So please make sure you remember, it doesn't matter how big the leading coefficient is. It could be the smallest one you see. What makes it the leading coefficient is it's the one in front of the biggest exponent. 42, the standard form, we start with the biggest exponent, 8x to the 4th, next smallest, 17x squared, next smallest, 4x, and the constant that has no variable, -3 or -3. And since 4 is the biggest exponent, the 8 in front of it is the leading coefficient. The degree of a polynomial is its biggest exponent. So you don't have to rewrite anything or change the order, you just look, where's the biggest exponent? It's 5, so that's the degree. 44, the biggest exponent is 4, so the degree is 4. Monomials, we don't have any of those here, are one single term. Binomials, which is what we have in 43, is 2 terms being added or subtracted. A trinomial is what we have in 44 because it's 3 terms being added or subtracted. To determine if something is a polynomial, there's 3 no-nos. No variables in the exponents. So the exponent can't have an x or y or whatever letter inside it. We can have no negative exponents. So x to -3 is a problem. We also cannot have variables in the denominator. That's the third no. So if we see any or more than one of those things, we know it is not a polynomial. So 45 is not a polynomial because there's a variable in the denominator. And I'll just repeat, the other no-nos are an exponent with a variable or a negative exponent. So since 46 has none of those red flags, we just say, oh, yes, it's a polynomial. Okay, a common issue I saw with ones like 47 is people tried to FOIL these. But we only FOIL when there's 2 parentheses being multiplied by each other. And these 2 are not being multiplied, they're being subtracted. So you really just combine the like terms. You really just say 7a minus 3a is 4a. 6b minus 7b is negative 1b. So you do got to make sure you apply the minus to both of these. 48, we have x squareds. Negative 3x squared plus 2x squared is negative 1x squared. 4x plus negative 5x is negative 1x. 2 plus negative 9 is negative 7. 49. Sorry again about my typo there. That should have been 3ab. This one does take a little bit of time. So start, we're distributing. So we got to multiply this term outside by all three of these. So 3 times 2 is 6. Now we're using the rules we've already talked about. A to the first times a to the third. We do 1 plus 3 and get 4. B to the first times b to the third. We do 1 plus 3 and get 4. So for the middle term, 3 is the only coefficient, so we just keep it. It doesn't change. Then a to the first times a to the fourth. 1 plus 4 is 5. B to the first times b squared. 1 plus 2 is 3. For the last piece, 3 times 5 is 15. A to the first times a to the first is a squared. 1 plus 1 is 2. And that's the only b, so we just keep it as it is. And we cannot combine this any further because these are only like terms if their variables are all the same and their exponents are all the same. So it is true all of these have an a and a b, but they don't have the same power of a and the same power of b. 50 we'll distribute as our first step. So 4c squared times c is 4c cubed. C squared plus, or times c to the first, 2 plus 1 is 3. 4c squared times 7. 7 times 4 is 28. We just keep the c squared. Then we have to distribute this to all three of these. And you've got to make sure you remember to keep this negative or this minus sign with it. So it's negative 3 times 4 is negative 12. C times c squared is c cubed. Negative 3 times negative 5 is positive 15. C times c is c squared. Negative 3 times 2 is negative 6, and we just keep the c. Now these do have some like terms, because you see c cubed, c cubed. So 4c cubed minus 12c cubed is negative 8c cubed. Then we have two terms with c squared. Positive 28 plus 15 gives us 43c squared. Then we just add this one c all by itself, so we get minus 6c. It's a little better. Okay. Don't worry, we'll take a break again in about 10 problems or so. We'll get there. To solve for x, we're going to start by distributing. Negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. And don't forget this plus x that's kind of hanging out here by itself. And the right side, we'll just rewrite it, nothing changed. Now on the left side, I have like terms that we can combine. Negative 2x plus 1x is negative 1x. Everything else is written the same. So I've told you before, when there's variables on both sides, I like to combine them first. Excuse me, so I'll add 4x to both sides. Negative 1x plus 4x is 3x. Then I'll add this 2 to both sides to get it out of the way. I get 3x equals 9. Then I divide both sides by 3. And 9 divided by 3 is 3. (52) we have to FOIL. So we multiply the first terms together. So actually, let me pause. I want to make sure you see the difference. These are being multiplied. There's nothing written in between these two parentheses. That implies that we are multiplying. Whereas on 47, there is a minus sign right there. So that tells you we're not multiplying these two things together. We're subtracting them. But on 52, we are multiplying them. That's why we have to do FOIL. 3x times x is 3x squared. 3x times negative 2 is negative 6x. 5 times x is 5x. And 5 times negative 2 is negative 10. And we do have these two like terms right here. Negative 6x plus 5x is negative 1x. Whereas these two terms, since they have no like terms, stay the same. Remember, remember, remember. Squared means times itself. So x minus 9 squared means x minus 9 times itself, x minus 9. Then we FOIL x times x, x squared. X times negative 9, negative 9x. Negative 9 times x, negative 9x. Negative 9 times negative 9 is positive 81. We again have two like terms that are just x's. Negative 9x minus 9x gives us negative 18x. But the 81 and x squared stay just as they are because they have no like terms. Okay, 54. Begin. We have to multiply this piece by all three terms first. So 6 times 3 is 18. B times b squared is b cubed. Six times negative 5 is negative 30. B times b is b squared. 6 times 4 is 24, and we just keep the b that we had in the 6b. Now we have to multiply everything by the 5. So 5 times 3b squared gives us 15b squared. 5 times negative 5b is negative 25b. And then 5 times 4 is 20. This is the only b cubed term, so it just stays as is. But we have two b squareds. We have a negative 30b squared and a positive 15b squared. Negative 30 plus 15 is negative 15b squared. Then we have two b terms, b to the first. Positive 24 minus 25b is negative 1b. And then this is the only constant, so it just stays as it is. Okay, we're switching over to factoring now. Another way they could word this, I don't know why they don't, but you could say factor out the greatest common factor. So when you see them mention factoring and the distributive property, they're really saying, what do the pieces have in common that you can pull out front? So these two both have 4 in common, so I can pull that out front. They both have at least 1 k. So if I take the 4 away from that, and I take one of its k's away, it's now k squared. 8 divided by 4 is 2, and since I took its k away, it has no k. The reason they talk about the distributive property is that we're really just doing the distributive property in reverse. If you were to distribute 4k times k squared, you get 4k cubed, then 4k times 2, you get 8k. Now you don't have to check your work that way, but that shows you that what we did to factor is correct. 56, big dog. We look to see what number all three of them have in common. Well, 15, 9, and 3 are all divisible by 3. We have a j squared to the 4th and cubed, so they all have at least 2 j's. K cubed, k to the 1st, and k squared. So since this one only has 1k, we can only pull out 1k. So we do 15 divided by 3, which is 5. J squared divided by j squared, that's just 1, so it basically disappears. K cubed divided by k gives you k squared. Because we had 3, we were taking 1 away. 9 divided by 3 is 3. J to the 4th divided by j squared is j squared. Because we had 4, and we took 2 away. And we took away the only k we had, so there's no k left in this middle term. 3 divided by 3 is 1. J cubed divided by j squared, so 3 j's minus 2 j's is 1j. And then 2 k's minus 1k is k. So you can see it there too, same answer. And not that you have to, but if you were to distribute this back into all three of those, you'd end up with the answer, or the question we started with. So as far as knowing when to do what kind of factoring, when you see them say distributive property, just look for the greatest common factor and pull it out front. When they say factor and there are 4 terms, that's when you need to group things in 2 pairs. So I put parentheses around the first 2 terms, and put parentheses around the second 2 terms. And then I look and say, what do these 2 inside have in common? They have a 5 in common, and they both have an A. So when I pull out 5A, what's left is A minus 2B. When I look here, I could say, what do these 2 have in common? That would just be the number 6. So I pull a 6 out. 12 divided by 6 is 2. 6 divided by 6 is 1. So then we run into an uncommon problem where the 2 insides of the parentheses don't quite match. A minus 2B and 2B minus A. We need the A to be in the front. So the way we can fix that, the way we can reverse the order inside, is by changing the number outside to a negative. That allows us to flip these around. I could explain more about why if you wanted to. I'm just going to tell you, when one's backwards, change the outside number to a negative and flip them around so they match. So then we have 5A minus 6 times the A minus 2B. Same process in 58. We have 4 terms. So 4 terms triggers and tells us we need to pair them into 2 pair, which I've done here with the parentheses, then factor out what they have in common. 3 goes in evenly to both 12 and 9. They both have at least one x and at least one y. 12 divided by 3 is 4. The y's go away, and one of the x's, leaving one left. 9 divided by 3 is 3, and we took away both the x and the y, so that's why it's just the 3 now. Five goes evenly into both 20 and 15, so we'll pull out a 5. 20 divided by 5 is 4. 15 divided by 5 is 3. So we have a match here, 4x plus 3, 4x plus 3. So that can be taken out by itself. What's left is 3xy plus 5, right there. Okay, last page for this video. 59 and 60 are the same process. So you're welcome to pause and look at it, or look at the, that's what I want, the written key that's on here, but I'll just briefly make sure you see 4 terms, put them in pairs, pull out what the first pair has in common, which in this case is 4a, pull out what the second pair has in common, which in this case is only b. Then you have a minus 4c and 4a plus b. Okay, 60, I've paired them up. These both have a y in common, so I pull out a y, leaving that to be 4y plus 3. These both have 3 in common. 12 divided by 3 is 4. 9 divided by 3 is 3. So 4y plus 3 matches. I'll put that out front. Doesn't matter if it's in the front or the back. And what's left is y plus 3 as the other term. Now here's the factoring everybody loved. When there's 3 terms, and you're just told the factor, this is where you need to think about what multiplies to be the last number and adds up to the middle number. Or when you have a number in front of x squared, you think, okay, I have to do 2 times 5 first. So I have to think, what multiplies to be 10 and adds up to 11? So that would be the numbers 1 and 10. So I first wrote x plus 1 and x plus 10. But then while we tried to hide the 2 by multiplying it, combining with the 5, it comes back all the time. Oh dear, we can't reduce this any farther, so I bring the bottom up and make it 2x plus 1. 10 divided by 2, I can, it's just equal to 5. So on 62, you think, all right, what multiplies to be 11 and adds up to 6? Well, we run into a problem, because there's only one pair of numbers that multiplies to be 11. 1 and 11. There's no way to add or subtract 11 to make it equal 6. So this is unfactorable. You can write unfactorable, or you can just write prime. 63 will be similar to 61. We multiply 2 times negative 15, get negative 30. Now our goal is to figure out two numbers that multiply to be negative 30 and add up to negative 1, because there's an understood 1 right there. So negative 6 and positive 5 accomplish that goal. They multiply to be negative 30, and when added together, they give you negative 1. So I wrote x minus 6 and x plus 5, but then that 2 came to divide and conquer us. So I do 6 divided by 2, 5 divided by 2. 6 divided by 2 is 3. This I cannot reduce, so I bring the 2 up, write it as 2x plus 5. So I'll admit, the first time I started to do number 64, I did it wrong, because I forgot rule number 1 of factoring. So I started by saying, all right, I'll do 3 times 45 and then figure out what will add up to negative 24. It's like, no, you have to look first. I didn't look on the others, but it also didn't apply on the others. Is there any number that evenly goes into all the terms? Well, yeah, there is. These are all divisible by 3. So remember rule number 1 with factoring. If there's something that goes evenly into all the numbers, pull that out first. So since they're divisible by 3, I can factor out a 3. That just cancels that 3 out. Negative 24 divided by 3 is negative 8. 45 divided by 3 is 15. Then, with what's left inside, we say what will multiply to be 15 and add up to negative 8. So it should be negative 3 and negative 5, because those will multiply to be positive 15 and add up to negative 8. So we get 3. Don't leave that alone. Don't forget it. It's still part of the answer. X minus 3, x minus 5. Okay, 66. Oof. So we got to figure out what multiplies to be 60, negative 60, and adds up to positive 6. So I listed all the possibilities, and not a single one of them, even though there's so many choices, can add up to positive 6. So that is prime. It is unfactorable. And I didn't do this to teach a lesson. I really did forget rule number 1 yet again on number 66. So I started saying 6 times 4 is 24. What multiplies to be 24 and adds up to negative 14? And I realized, I have to do rule number 1 first. It's weird. They call it number 1 like you're supposed to do it first, right? Oh well. So since these are all even, what you actually have to do first is to factor out a 2. So 6 divided by 2 is 3. 14 divided by 2 is negative 7. 4 divided by 2 is 2. Then I do the bottoms up method. I say 3 times 2, that's 6. I need something that multiplies to be positive 6 and adds up to negative 7. So I pick negative 6 and negative 1. Then that 3 we tried to ignore and push away came back. 6 divided by 3 is 2. This will not reduce, so I bring the 3 up, bring the bottom up, and get 3x minus 1. And that 2 we pulled out at the beginning is still there. It's still part of the answer, so don't leave it behind. All right, I'll do one more video to finish the rest. That will be part 3.